Greetings and welcome, friends. We were like solving and rewriting equations and literal equations and formulas yesterday. And let's solve this literal equation for y. And you notice the first thing that's different than what we've usually done is that there's two variables here. And they told us to solve for y. And what that means is I'm going to pretend that the x is just some number. So this would be like if it said 21 plus y equals 7, and I'm solving for y. So how could I move this 2x? Friends, how could I move? Yeah, it's a positive 2x, so the way I move it to the other side is subtract it. Now I'm writing that here, although these are not like terms. I do plan on putting it right in front of the 7, though, is my plan. My plan. So I'm going to have y equals, don't worry, gentlemen, I got it, negative 2x plus 7. You just worry about this literal equation. So notice y is now by itself, which was what my goal was. It is solved for y. I love it. I love it. Let's take a look at un otro problema, mis amigos. Yes. Yeah, perfect. Question 10. We are still solving for y, so let's target the y. Oh, man, I didn't box that really good. And for the y, I'm going to pretend that all the x's are just numbers. And, yeah, don't do that there, Ethan. I just told you not to. That's all, man. Don't worry, it's cool. So, two things are happening to the y. It's being multiplied by 9 and subtracted by 2x. What thing should I move first? Should I move that 9 or the 2x? I got a peace sign. I'm guessing that means 2. We're going to deal with subtraction before we deal with multiplication. If I deal with a 9, I'd have to divide everybody by 9, and that's going to create fractions, so that's why I'm waiting. And hey, look at this. There's actually another x term over here. So let's add 2x underneath that, and we'll combine those like terms. Why not, shall we? So, ladies. 16x plus 2x is 18x's plus 9 equals, those x's canceled out. I've got 9y. All right, what are you guys thinking now? How do I get the y by itself? I like it. Divide both sides by 9, and everybody gets divided by 9. And hey, conveniently, these are actually divisible by 9. It's not going to make fractions for us. 18 divided by 9 is 2, so I'll write that as 2x. 9 divided by 9 is 1, so that's plus 1 equals, those 9s cancel out. I get y. And let's flip it around because I like to have the variables on the LHS left-hand side, if you know what I mean. So y equals 2x plus 1. All right. I'll go over some of the other ones afterwards if you'd like. I did. Y equals negative 2x plus 7. So the goal is to get the y by itself. Oh, it's all right. Here's question 28. So here's the one where, hey, I mean, this is the first time you've seen stuff like this was yesterday. These things get crazy, right? Crazy tricky. Look at all, like, there. I only see, like, the only numbers I see in here are 2, and then there's a whole bunch of other letters, and there's even a Greek letter in here. Man. So I want to solve for h here, right? I like saying it. So yeah, get everything away from h. So that means this 2 pi r is like the coefficient of h, and that this 2 pi r squared is just like some constant being added to it, is the way I'm pretending. So I'm going to 2 pi r squared. Yeah. Pi. That's this that's that symbol there. Pi. So let's see. I've got to move this 2 pi r squared. I'm going to do that by subtracting 2 pi r squared from both sides of the equal sign, right? So, Amity, can I combine the s and the 2 pi r squared? Are those like terms? Nah. So I'm just going to write that as s minus 2 pi r squared equals These canceled out, and I'm left with 2 pi r h, right? So Amity, I've got that 2 pi r in front of the h. It's acting like a coefficient. I'm just pretending that r is some number. So is there a way I could get rid of all of that in one move? How could I? Do you know? Yeah, division. I like it. Divide both sides, and everybody gets divided by 2 pi r. Right? So watch what happens here. These, the 2's cancel, the pi's cancel, the r's cancel. H is by itself in like a combo move, right? And here, these 2's are going to cancel. These pi's are going to cancel. And this r will cancel with one of the r's in the r squared. Actually, let me do a little side note for a second here. R squared divided by r is the same as r times r divided by r. And when I cancel that out, this r cancels with one of those, and I'm left with just one r. So that's why I write this and this, and there's just going to be an r left over, is kind of my logic there. So I'm going to end up with s over 2 pi r minus, everything's gone except for r, equals h. And now let's flip it around here. Why not? So h equals s over 2 pi r minus r. All right, the trick to doing these is just pretend the s and the r are just numbers. And pi is a number, that's right, 3.14159, infinitely long, non-repeating decimal, right? But we're just pretending my other variables are numbers. And I'm just getting the h by itself. All right. Let my students write this down. Let me fix my attendance in the meantime. Oh man, that makes my screen go blank when I Alt-Tab. Yes, not this caliber of question, but yes. No. So let's look at the last problem I'm gonna do for now, for this video anyway. I'll still help you guys out on some other ones in a moment. It says the average acceleration of an object is a equals v1 minus v0. Sometimes this is pronounced as v naught. By the way, the side note, v sub 1 and v sub 0, that does not mean v times 1. v1 is like the name of the variable itself. It's the first velocity. Yeah. Right. So squaring would be if I had superscript. These are called subscripts. So they're the same size font as that. And actually what's weird, I could even have v naught squared. And that would be weird looking. But this component here represents the variable. Question? A calculus problem? Acceleration can be thought of in a calculus type perspective, but we'll just keep it with this for now. They wanted us to solve for v sub 1. Okay? Actually, let me write this down a little bit larger here. So a equals v sub 1. Right, so everyone's writing this down. Did anyone think they got this problem right last night? Did anyone? Yeah? Oh. Let's see how it goes. So if I'm getting v sub 1 by itself, let's see. Devin, this is the opposite of the answer you usually give me. Here I have this division. How do I get rid of dividing by t? What's the inverse of dividing? Multiplication. Both sides by ta, t, ta, right? Multiply both sides by t, and watch this. I had to do this, by the way, before I dealt with that subtraction, because this fraction bar is a type of grouping symbol. And notice multiplying by t would in fact cancel out with dividing by t. So I'm going to have TA equals v sub 1 minus v sub 0. And I'm solving for v sub 1. That means I'm just pretending this says like minus 2 or something like that, right? I'm just pretending that's a number. How could I move v sub 0? Add them, right? Add v sub 0 to both sides. I'm going to have t times a, time times acceleration, plus v sub 0 is going to equal v sub 1. And then I could flip it around. V sub 1 would therefore equal this. T times a plus v sub 0. So make sure you're writing like the little sub 0 and sub 1 in tiny font, right? Kind of down like that. So thank you for watching, mis amigos. Adios.